into A-level computer science with the exam board OCR. So the first question that you might have will be, why choose computer science A-level? There's a lot of people out there, some very famous people, in fact, who put a great value on computer science, and in particular, developing programming skills. Steve Jobs, which hopefully you'll have all heard of, said that everyone in the country should learn to program a computer because it teaches you how to think. And even Albert Einstein, all those years ago, said something very similar, that education is not the learning of facts, but of the training of the mind to think. And that sort of sums up really what computer science is all about. And it's why a lot of employers and universities put a value on an A-level in computer science, because it shows that you've developed those analytical problem solving and thinking skills that are so useful in everyday life. If you are a mathematical logic kind of person, then this could be an A-level that you should think about doing. We will assume that you haven't done it before. Some people might have done GCSE, some people might have done an IT course, but we will assume that you haven't done it before, so we will start right back at the beginning, quickly move you forward so that everybody has a chance to succeed. So is it right for you? Well, I think it's very important to point out that computer science and ICT or IT are very different approaches to a common curriculum area. Whereas in ICT or IT, you might be using software to create solutions. So, for example, you might produce quite a complicated website or do some detailed graphical work. That's not what computer science is. Computer science is technical. There's a lot of theoretical knowledge, some of it quite difficult. And you will have to develop your programming skills to quite an advanced level. We will mainly be using Python, although during the course you do have to touch on HTML and JavaScript as well. There's 2 written exam papers, and then there's a programming project, which makes up the final 20%, which we'll talk about in a little bit. I would also like to point that there are some quite advanced mathematical concepts in this specification. So, you do need to consider that as well. So I've asked a few questions. Are you a logical thinker? Do you enjoy a challenge? Do you have an interest in programming? Are you resilient and determined? And do you want to develop your thinking and problem solving skills? And if you'd answered yes to those, then computer science might be an A-level that you want to think about for next year. So this is a little look at the content and assessment that I've lifted from the OCR specification. If you are interested in going into a little bit more detail, then you can find this on the web quite easily. Some of these topics you will think, oh, I already know that, we've done that before, but obviously for A-level, we'll go over that, but we'll go into more depth. The first one on there, input, output and storage devices, and of course, hopefully you'll have all heard of those terms before, and you probably think, well, that's easy, that's fairly straightforward. But as you look down the list, there's lots of other things on there that are much more complicated. So, for example, on the data structures, you need to be able to write a program that uses a binary tree or a graph. The algorithms, you need to be able to write different algorithms for searching and sorting. And there's some quite advanced mathematical work in there. So, for example, there's Dijkstra's shortest path algorithm and A-star algorithms, which are sometimes used in computer gaming for them to try and come up with a quick solution. It doesn't always work, but we will be having to look at those. A bit further down, elements of computational thinking. For example, if we're looking at abstraction and you were designing a game in the real world, we would have to think, well, what part of those real world can we ignore? What parts do we have to incorporate in the game? That's just a little brief sort of summary there. The last bit is the 20%, which is the project. So the theory is 2 written exams, 2.5 hours each, and those each will contribute 40%, and the project will give you 20%. Now, the project is the bit that a lot of A-level students really like. Now, I've given you a little snippet of some code there. I don't expect anybody to understand it, but I'm just showing you how quickly your programming skills will develop, perhaps from anything you might have done before, if you've done any programming, to what we do at A-level. And the other things that will be different is if you've done GCSE computing and you've done Python before, we're now going to be using graphical images and graphical interfaces and using the mouse rather than just keyboard input, etc. Of course, the program itself is always only going to be a very small part of what you get the marks for, because most of the marks will come from all the documentation that goes alongside it, the decisions you've made, why you've tackled it in a certain way, the research you've done, the testing, the evaluation, etc., etc. But that is the part of the course that a lot of students like, because they want to get, their teeth into something and they really want to sort of push their programming skills forward. So what about if you do A-level, what would you do afterwards? Well, there's lots of things. You could go into employment or for apprenticeship or for further study. So I thought I'd have a look on UCAS and see what computer science type courses are available. And they came up with these 5 areas: computer science, information systems, software engineering, artificial intelligence, and health informatics. And if you were to look at each of those, a whole other list would appear, and there was just endless and endless courses that were available. There's courses on web technology or cybersecurity, computer forensics, computer gaming, lots and lots of courses. And of course, within each course, you can mix and match modules, etc. So there is a massive choice out there if you wanted to go down this kind of route. One thing I would point out, though, is that some, not all, but some universities do require A-level mathematics for entry onto some of their computing degree courses. So if you were thinking that far ahead, it might be worth just looking at universities now that you are thinking would possibly be something you would consider, and just check out their entry requirements just to see if they were stating that you would have to have A-level maths. So if you've listened this far, then hopefully A-level computing is something that you are considering. So thank you very much. Bye.